Good morning, everyone. Myself Devika, working as assistant professor in the Department of Electrical and Electronics Engineering at Sri Muthukumaran Institute of Technology. Now we are going to discuss that subject on W25C04 Basic Electrical and Electronics Engineering for 2025 regulations. In this presentation, we have to discuss the topic bipolar junction transistor BJT. It is an important semiconductor device widely used for amplification and switching applications. Overview and introduction. It covers the structure, working principle, transistor configurations, testing methods, and application of the bipolar junction transistor. Introduction. See, bipolar junction transistor is a three-terminal 3-layer 2-junction 3-terminal semiconductor device and consisting of collector, base and emitter terminals. So it is developed in 1948 at Bell Labs. So it became a key component in the advancement of the modern electronics. Then importance of BJT. So semiconductor devices are the foundation of modern electronic systems. So the BJTs are widely used because they can function both as amplifiers and switches. So they are available in two types, NPN and PNP transistors. Then device architecture and working. So a BJT consists of three semiconductor regions. In an NPN transistor, the emitter and collector are N-type while the base is P-type. The PNP transistor has the opposite arrangement. That means the emitter and collector are P-type while the base is N-type. This structure enables current control and amplifications. These are the diagrams of architecture of bipolar junction transistors. So in N-type NPN transistor means the arrow mark is towards the emitter. In PNP transistor means the arrow mark is towards the base. Then overview of transistor design. So the transistor contains two PN junctions. So these junctions can be forward or reverse biased. So creating different operating conditions. So the term bipolar indicates that both electrons and holes participates in the current conductions. Then layout of terminals and BJT representations. So the base terminal is located between the emitter and collector and it is very thin. So the emitter and collector are made of the same semiconductor type while the base is of the opposite type. Then transistor currents. Three currents flow in a transistors. Emitter current IE denoted as IE, base current denoted as IB, collector current denoted as IC. So the arrow on the emitter indicates the direction of conventional current flow. For NPN transistors, the arrow points outward while the PNP transistor it points inward. How a transistor works. So for proper transistor operation, one PN junction must be forward bias and other is reverse bias. This biasing arrangement allows a small base current to control a much larger collector current. Carrier carrier movement in PN junction. So in a PNP transistor, poles move from the emitter to the base through the forward bias junction. A small number contribute to the base current while most reach the collector producing the collector current. Then current relationship in BJT. So according to Kirchhoff's current law, the emitter current is equal to the sum of collector and base currents. So IE is equal to IC plus IB. So the collector current mainly consists of majority carriers while a small leakage current exists due to minority carriers. These references include standard books on electronic devices and digital circuits used for preparing these presentations. Thank you.